integration. So this is what I'm taking today. Okay. Now, guys, let's understand the concept of integration. Now, most of the people might have felt that integration is a bit tougher compared to what your derivatives, right? So there's a reason for that, particular reason for that. What's the definition of integration? If you want to have a proper definition of integration, it goes something like this. If a real valued function f of x is such that d by dx of f of x, that is derivative of f of x, is equal to some capital F of x plus c. F of x, that is capital F of x. And this capital F of x function, f of x is a continuous function. Let us assume that this is a continuous function. Okay, then the antiderivative of capital F of x is, so what do you mean by antiderivative? Opposite of derivative or inverse of a derivative. That is, I'm taking this operator on the other side. So it is written like this. Antiderivative is written by like this sign. This is an integral sign. So integration is an antiderivative. Always remember. So antiderivative or integral sign of f of capital F of x dx is working out as small f of x plus arbitrary constant c. This is what is the definition of integration. So if a derivative function exists like this, then the antiderivative of the right side function will be the original function small f of x plus some arbitrary constant will come across. Now, why arbitrary constant is coming is it's a problem with integration. The reason why is very easy. Let us say derivative of 10, a value 10 is 0. Derivative of 333 is 0. Derivative of any other constant you take, it's always 0. But when I try to integrate 0, I know it's a constant, but I don't know what is the value of that particular constant. That's the reason why we had to define a special term known as integrating constant or arbitrary constant. C is known as what? Sometimes known as integrating or sometimes also called as arbitrary constants. Okay, so this is what is the definition of integration. Now, compared to other definitions, this is quite easy to remember and this is quite easy, people may think. But remember, this is a very bad definition because this is a comparative definition. Why I call this as bad definition? It's a comparative definition. Okay, comparative definition, only if that comparison exists, then it's quite easy to manage. Otherwise, it is very difficult to manage. In gate problems or whatever numericals of integration are there, you don't know what is this original derivative function. Okay, you don't know this small f of x. You are just given randomly some capital F of x and they are asking you to integrate it. Okay, that's where the trouble starts. So that is why it is a trial and error method. There are some methods to try it, and whichever method works out, we will solve it. If you are not working out, you try by other method. That's it. That's what is integration. That's the reason why people find it quite difficult to manage integration. Okay, this definition is the core reason for that. Is there any other better definition? Till now, no one has been able to come across. If you are able to come across, that will be a very big help in mathematics. Okay, till now, no one has been able to consistently and properly give a better definition than this. Okay, so this is what is integration. Now, integration geometrically actually is what is integration. If you ask me, then I can explain it geometrically also. If I take a graph like this, okay, this is some graph. Let's say this is some random function. Let's say these are the limits on which the function is operating. So what is integration technically? If this is your function f of x, integration is this area. Let me shade it. If I shade this area, this is what is integration. The shaded red region is your integration. Okay. This is what is actually, sorry. This is what is your f of x. That is integration of f of x dx. Now here I am restricting it to some variables a and b. Okay. Now, for those who are asking what is integral, when I put limits to an integration, it becomes a definite integration. Remember, same definition is similar. The only difference is in a to b, small f of x dx or small f of x dx is equals to capital F of a. Sorry. Capital, just hang on a minute. Oh, sorry. So we did with capital F of x. No? Let me recorrect it. The capital F of x is equals to small f of x limit from what? A to b, right? Technically, your c should come. Let's write the c properly from limit a to b. So when I apply the limits, what do I get? Small f of b plus c minus small f of a plus c. So the final answer is f of b minus f of a. So this is what is the extension of that is limits within an integration within a limits. That is integration where there is restriction to the x values. X values are lying only between what? A and b. This is what we call as definite integration. Okay, so I hope this is clear. So let's now go to the problem side. Okay. Now, guys, I'm directly jumping into the problem. Rather, I will discuss the concepts within the problem. Okay. So let's deal like that. Now, before jumping into problems, I always tell students how I approach an integration problem. Okay. There are various ways to approach an integration problem. Trial and error, but blindly trial and error doing is not a good thing. Okay. So you have to be always careful. You just don't blindly do a trial and error. You rather develop an approach. So how I develop the approaches, I always start with, first I will check with standard formulas. There are some integration standard formula. That is what I will do. Whether standard formulas are valid or not. But remember, it can be directly. Sometimes directly standard formulas can be applied. Sometimes it is indirectly. Sometimes you will have to modify, especially integration involving some trigonometric functions. Then you will have to use some trigonometric relationships to convert into standard formula. Okay, so that's the first approach. If that first approach fails, if I'm not able to solve by this, then I go for the next method, that is substitution method. Substitution method. Okay, that is whatever complicated function is there, I'll try to substitute that function to a different other variable, and from there I will try to see whether I'm getting a simplified function in the end or something related to standard form. If I'm able to replace all the dx variables also, then okay, I'm okay with substitution method. If substitution method fails, then I go for third idea known as partial fractions. Now remember, partial fractions are only applicable when what? Denominator is what? Algebraic function. Okay, denominator is what? Algebraic function. Then only it works. Otherwise, there is no point in doing partial fractions. Okay, if denominator algebraic functions are factorizable, then apply partial fractions. That's the easiest one. If this fails, then I go for properties of definite integration. Properties of definite integration. Your gate problems mostly are actually involving this particular section. That is properties of definite integration. There are some 7 to 8 properties are there. You'll have to apply that to simplify the function. In gate examination, what we have seen is most of the time, almost 80 to 90% of the times, you're going to get integration which is definite. The reason indefinite integration is not mostly asked in gate paper because of the objective nature of the question. Our question paper is objective, right? So to get objective questions, I cannot ask indefinite integration. Because indefinite integration, if someone else selects a different method and someone else will select another method, both may get a different answers and both are right also. So that creates an conundrum, how to evaluate the paper. So that's the reason why we don't go for properties of definite integration. Now, if that is failing, then we go for the product rule. Product rule of integration. Okay. So this is what is your final step. Okay, after all the things failing, I go for product rule of integration. Never, product rule of integration should never be your first step. Okay, now if this you are a 11, 12 standard student, you could have stopped here. But we are BTech students, right? So let's go for the next method, sixth method, and that is applicable from our BTech topic. I'm not going to discuss that today itself. The reason is some other topics are needed, so that will be discussed in that particular topic. Okay. So what all things can apply? Like, have you heard about transform theory, right? Transform theories. A lot of transform theories. The famous one are this thing: Laplace, Fourier, then Z transforms is there. Okay, transform theories or standard or Gaussian distributions. Gaussian distribution is coming in your this thing, the probability topic. We sometimes also call this as normal distribution. Sometimes in gate questions, some integration problem related to Gaussian distribution has been asked. So this transform theories or Gaussian distribution can help us in solving the paper, solving the question. So this is the main concept. So this is the approach. I start with the problem. Okay, remember this approach is designed for gate paper. So focus only for gate paper. For other papers, I will have to see the questions and then accordingly I have to modify my approach. But this is generally the whole approach that I set up. So I just randomly don't start to do an integration. Rather, in my mind, this elimination order is working out. I start with first, okay, then I go for second, okay, not okay, then go for third. If I'm not able to do, go for fourth. Like that, I will go step by step. This way, I don't have to. I have developed a proper structure. So just randomly selecting any trial and error sometimes may not work in your favor, because if you miss one of the steps, then there's a problem. There is a probability that you are not going to solve the problem. So to minimize that, I'm developed this approach. Okay, so this is what I said. This start to do the problem with. Now let's jump to some problems so that we can cover it up. Okay, so let's start with first integration. Now here, what is function given to us? Modulus of 1 minus x. So when I ask you to do the integration, first of all, understand what is this mod of 1 minus x. Let's define this function. Mod of 1 minus x is 1 minus x if 1 minus x is greater than or equal to 0. Negative value of 1 minus x if 1 minus x as a whole is less than 0. This is how we define mod x. Okay. So instead here mod x, the term is 1 minus x. So now simplify it out. Okay. 1 minus x when, if I take minus x on the other side, becomes positive x, right? So that is 1 greater than or equal to x. That is x is less than or equal to 1. If x value is less than or equal to 1, I will go for 1 minus x. Now, if I put minus sign here, my function becomes x minus 1. Now, if I take x there, so x is greater than 1. So for x less than 1, I have to select 1 minus x. X greater than 1, I have to select x minus 1. Now, guys, you can see here that the 1 is the point which is within the limit 0 to 2. If you check the limits of the function 0 to 2, 1 is between that. So how to cover up that? That's what I'm showing you. So my integration function is 0 to 2 mod of 1 minus x dx. Right? Now, remember that for definite integration, there's a famous property. Integration a to b f of x dx is equals to integration a to c f of x. That is, integration can be split within the limits, plus integration c to b f of x dx, provided c is lying between a and b. If c is a value which is lying between a and b, I can split the integration like this. That's what I'm trying to do here. Here my function is fluctuating at one point, that is value 1. So integration will be 0 to 1. So within 0 to 1, what is my function? That is less than 1. 0 to 1 means less than 1. So 1 minus x. 1 minus x dx plus 1 to 2. My function is x minus 1 into dx. Now properly do the integration. How to do the integration? You have to split it up. So what is that? Let's start with 1. Integration can be split between the sums. Okay, sum plus or minus. I can split up the integration. So 0 to 1, 1 dx minus 0 to 1 x dx, right? Similarly, 1 to 2 x dx plus, plus minus 1 to 2 dx. Okay, now let's do the integration. Now I don't actually split it up. I just for doing the sake, I just split it up because I'm doing the first problem. Normally, I don't do this. I directly jump from here to the answer. Okay, how I jump is inside function. I know it is going to split up. So one day integration with dx is what? X. Next, minus x dx. Minus is not the issue. X dx integration. So for that, you have to remember this formula. Okay, what is integration of x raised to n dx? X raised to n plus 1 divided by n plus 1. So minus x square by 2. Limit is from 0 to 1. Plus. Second function is what? X minus 1. So if I do x dx integration, it is x square by 2 minus x. X square by 2 minus x. Now the limit here is 1 to 2. Okay, now apply the limits. When I put the upper limit 1, 1 minus 1 square by 2, that is 1 by 2. If I put 0, lower limit is 0. So no need of writing that. Normally minus and lower limit. So 0 minus 0. That's what I'm going to get if you want to write it. Plus. When I put upper limit 2 here upper limit is 2. So 2 square by 2 minus 2. Then what? Minus 1 by 2 minus 1. Right? 2 square by 2 is what, right? 2 square is 4. 4 by 2 is 2. So this term entirely is 0. This is obviously 0. So the only term remaining is 1 minus 1 by 2 is what, right? 1 by 2. That's 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. Then again minus is there here. So plus 1 by 2. 1 by 2 plus 1 by 2 is 1. That's it. So integration area is what? 1. I think so option is there like that. Yeah. Answer is option A, 1. That's it, guys. So this is what is the integration. Is it clear? I started a simple problem. Now let's go for a bit more tough problem. Okay. Thank you, guys. Okay. Now, let me introduce the next problem. So you can see 1 in the 0 to 1 x 1 minus x dx. Okay. Now this is a bit complicated one. Okay. Now why? I can actually do by standard form. But a troubling term is 1 minus x to the power of 5. Now if you remember binomial expansion, then it's okay. What is binomial expansion? For those who don't remember, a plus b the whole raised to n is what? A raised to n plus nc1 a raised to n minus 1 b plus nc2 a raised to n minus 2 b square. Like that it will go up to what? ncn b raised to n. If you are taking a minus b whole raised to n, then the only difference is you have to introduce alternate plus minus sign. Same problem, but alternately you have to introduce plus minus sign. Minus, like that it will go up to what? Final term ncn b raised to n. Now whether this is plus or minus depends on the value. Okay, whether n is even or odd, don't bother with that. That's not an important part. So these are quite similar for similar expansion series. Writing this will create a very long function. So there is another way to cover up this up. Now let me show you how I manage this up. Okay. By introducing a substitution idea, I can actually manage this up. How I manage this up? Let me show you. Who is a complicated one? 1 minus x to the power of 5. Like inside 1 minus x is the complicated. So let's say let 1 minus x is equal to some variable u. So I'm introducing substitution method. Okay. Although direct application can be done, now here substitution is quite good. This is now how I'm actually violating my rule in the sense that this is based on experience. Okay. Some problems when you do in some particular way, you can do it very quickly. So here that complicated function 1 minus x, I'm changing it out. Okay. So just changing out 1 minus x is not the end. You also have to find a relationship for dx. So if I take derivative with respect to x, I get minus 1 is equals to du by dx, or I can write it as dx is equals to negative value of du. Okay. So I found out the substitution for dx also. Now, if 1 minus x is u, then what is x? 1 minus u. Just rearrange it. Now, normally after this, people tend to change the limits, but I don't change the limits. I'll show you how I manage it. So I'll keep the original limit, which is that 0 to 1. Now, here there is outside x function, right? So I have to replace this x function, I will be replacing by 1 minus u. 1 minus u. And the other one function I will be replacing, that is 1 minus x, I will be replacing by u. That is u raised to 5 du. Not du. Technically it is minus of du, right? Dx should be replaced by minus of du. Now, when I introduce this minus sign here and u raised to 5 multiplied inside, what do I get? I'm not doing the integration, I'm multiplying by negative and u raised to 5 inside. So minus u raised to 5 plus u raised to 6. So let's write it like this. U raised to 6 minus u raised to 5 into what? D. Now I can simply do the integration. U raised to 6 integration is what, right? U raised to 7 by 7. U raised to 5 integration is what? U raised to 6 by 6. Limit is from where? 0 to 1. Now, since I didn't change the limit, you have to be careful. You have to come back to the original variable. So before substituting the limit, I come back from u to x. What is u? 1 minus x. So 1 minus x to the power of 7 by 7 minus 1 minus x to the power of 6 by 6. Limit is from 0 to 1. See, the reason why I'm doing like this is because when I substituted it, I didn't change my limits. Now you might be asking, then why can't we change the limits? Sometimes what I felt is, I don't know about you, but when I'm trying to change the limit, there is a possibility that I will make a silly mistake. So function replacing is quite easy, but sometimes when I substitute the values, or when I put the values and try to find out the values, there are some confusions coming. So I'm completely avoiding that confusion by never changing the limits. But one more step I have to additionally do before applying 0 and 1. I have to change from u variable to the original x variable. That's the extra step that I want to cover up here. Now you just have to apply the limit. So one upper limit, 1 minus 1, 0. Again, 1 minus 1, so 0. So upper limit is 0 entirely. Minus, what is the lower limit? 0. So 1 minus 0 is 1. So 1 by 7 minus 1 by 6. So if I take this inside, so 1 by 6 minus 1 by 7. Now cross multiply it. So 7 minus 6 divided by 7 into 6 is what? 42. So answer is 1 divided by 42. That's it, guys. Now for a person who does the expansion, you'll be also getting 1 divided by 42. The only thing is expansion terms will be very larger. The answer is option A. That's it. So this is how I solve an integration problem. So this is what is your substitution method looks like. Okay. So always in my mind, I start with standard formula. I could have done standard formula here, but that 1 minus x to the power of 5 expansion, I know it's a very large term. It will be around 6 terms will come in the expansion. So that makes it very, very tedious. So that's why I jumped the method to second approach, that is substitution method. Now, next. Now, minus pi by 2, integration from minus pi by 2 to plus pi by 2. x raised to 10 log of 1 plus sin x divided by 1 minus sin x into dx. Okay, so let's work it out. So our question is what? Limit from minus pi by 2 to plus pi by 2, x raised to 10 log of, this is natural log, okay? Right, modulus sign is not the issue right now. Let's worry later at that. 1 plus sin x by what? 1 minus sin x into dx. Okay, so this is our function here. Now what is the answer of this? Okay, so guys, this is a very complicated function. First of all, there is no standard formula for log function. So obviously standard formula cannot be applied. Now substitution method, the problem is which will I substitute? Will I substitute for log? Will I substitute for the inside sine function, or will I substitute for algebraic? And the troubling part is they don't have any other connection except log and x function. They may have a derivative connection, that is log of derivative of log x is 1 by x. There is some possibility, but otherwise, but inside the log there is not just log x. It's log of trigonometric function, right? That again creates its own issues also. So that's why substitution method is also failing. Now, since there is no algebraic function in the denominator, I cannot even apply partial fraction. So the approach that I have to go for is properties of definite integration. So what property of definite? Whenever you see same value with negative and positive sign of limits, there's a famous property, odd even function property. Minus a to a f of x dx. It has two types of values depending on the condition. 2 times of 0 to a f of x dx. 0. This is when what? F of x is what? Even function. This is when f of x is odd function. Okay. So if it's an odd function, the answer is 0. If it's an even function, you can write 2 times of 0 to a. Now let's check it out. What is it? So before that, what's an even function? Even function idea is very quite easy. If, what is the condition for even function? F of x equal to f of minus x. That is even function. That is by introducing minus x, I get the same function. What is the definition for odd function? F of x equal to negative value of f of minus x. That is when I introduce a negative sign, I get negative value of the original function. So let's see. What is our f of x function here? You see in the limits, what is that? X raised to 10 log of 1 plus sin x into log of into 1 minus sin x, right? Divided by 1 minus sin x. So x raised to 10 natural log of 1 plus sin x divided by what? 1 minus sin x. Now to test out that theory, let's introduce f of minus x. So wherever there is x, now replace by minus x. So minus x to the power of 10 log of 1 plus sine minus x divided by 1 minus sine minus x. Okay, so minus x to the power of even power is always positive, x raised to 10 itself. So that's even function. What about the log inside function? Sine of minus x, if you remember, sine of minus x is minus sine x. So this becomes 1 minus sine x. Now minus sine x, minus of minus becomes plus. So 1 plus sine x. Now see this function and your original function f of x. Are they same? No, because the inside log is not same. Now there's a famous property. Log of a raised to b is equal to b log a, right? I can write like this. Now see what I'm going to do here. So my f of minus x will be x raised to 10 into log of, to compare with the original function, I'm taking the reciprocal of this. So what is the reciprocal of this? A divided by b is reciprocal is b divided by, na? So that's what I'm doing. The reciprocal, I have to always introduce this negative sign, negative power, right? Now, as I discussed, anything in the power can be taken as multiplication. So minus x raised to 10 into log of what? 1 plus sin x divided by 1 minus x. sorry, 1 minus sin x. Okay, so this is what negative value of f of x. No? This is minus of f of x, right? So when I introduce minus sign, I'm getting my negative value of the original function. So negative value of original function means it's an odd function. Therefore, f of x is an odd function. Now, if it's an odd function, the answer is quite easy, man. Why the answer is easy? If you see the property, where is that? Yeah. If it's an odd function, my answer is 0, right? That's it. Our answer is over. So integration minus pi by 2 to plus pi by 2 x raised to 10 log of 1 plus sin x by 1 minus sin x into dx. The answer to this is 0. That's it. So the answer of this integration is 0. So this is what is the odd function property that I'm applying here. I hope this is clear. Is it clear? Please respond. Okay. So problem number 4 is 0 to pi by 2 sin x minus cos x divided by 1 plus sin x cos x. Okay. Zero to pi by 2 sin x minus cos x divided by what? 1 plus sin x cos x. Now guys, if I go for standard formula, the problem is if I get sin x or cos x alone, there is an integration. The problem is this is a complicated function of sin and cos. So I cannot just say it's a trigonometric relation. So that doesn't work out. Actually, there is a way of working it out even using trigonometric relation, but that's a very hectic way. Okay. You can divide by what is that cos x, and then there's a way to that, but that's a very complicated way. So that's not working. What about substitution method? The problem is again the same thing. What will I substitute? Will I substitute for sin x or will I substitute for cos x? Even if I substitute for sin x is equal to u, how will I replace dx? There is no cos x to dx function. So that is also failing. Then obviously denominator is not a algebraic function, so partial fraction is out. So the only method that is available is actually, there are few more, but the main method available is definite integration property. So the property that I'm going to discuss is the most important property. Now, how to realize whether this property is needed is, remember, whenever you see an integration problem, check whether what is the troubling term here, what are the troubling functions here, or limits. Sometimes limits are complicated, sometimes the functions are complicated. Now, in this particular problem, function is complicated. We can see from the question, the complicated one is function. So whenever function is complicated, there are two ways to replace a function. One is substitution method, which we discussed, and we said that it's not possible. Second method is actually what is known as a property of definite integration. I will show you that property. It goes like this. If we have a function from 0 to a f of x dx, the same integration is equal from 0 to a f of a minus x. That is, instead of x, if we replace a minus x dx, the answer is still the same. Similarly, instead of 0 to a, let's say my limit is general value a to b, f of x dx. Let's say if that is the case. So a to b, f of what? A plus b minus x into what? Dx. Okay. So this is the property that I'm going to apply here. So let's come back. So my original integration is what? 0 to pi by 2 sin x minus cos x divided by 1 plus sin x cos x. Right? This is my original integration. Okay. Now, according to the property, I can replace this integration by 0 to pi by 2 sin, instead of x, I will be replacing what? Pi by 2 minus x. Now, not only in one function, I have to replace wherever there is x, all functions, all x must be replaced by pi by 2 minus x. 1 plus sin pi by 2 minus x into cos what? Pi by 2 minus x. Okay. Now let's do the simplification. I is equal to 0 to pi by 2. Sine pi by 2 minus x is what, right? Cos x. Right? You remember, right? Sine pi by 2 minus x, that all silver teacups, that idea. And that's what I'm doing. Pi by 2 minus x is first quadrant. Whenever you add by pi by 2 or subtract by pi by 2, the logic is you have to convert sine into cos or cos into sine. So sine pi by 2 minus x is what? Sine pi by 2 minus x is equal to cos x. Similarly, if I say cos pi by 2 minus x, that value is what? Sin x. Now I am saying it is plus sin x is because whatever function, whatever this angle is, it's in the first quadrant. Pi by 2 minus x means you are coming in the first quadrant. So first quadrant is sine becomes cos, but it is positive. Similarly, cos becomes sine, but it is still positive. Everyone is positive in the first quadrant. Cos x, first function will become cos x minus sin x divided by 1 plus, what is that? Cos x into sin x. Okay. Now you might be asking what is the importance of this. Okay. Let us say this is value 2 or this is equation number 2 and the starting is equation number 1. Okay. Now what I'm doing is adding 1 and 2. Adding 1 and 2. Okay. So I left side what will happen? I plus I 2i. I will get 2i. Now 0 to pi by 2. You can see something here. 1 plus sin x cos x is same as 1 plus sin x sin x cos x. 1 plus cos x sin x can also be written as 1 plus sin x multiplied by cos x. There is nothing difference in that. So first function and second function denominator is same. If denominator is same, I can simply add up the numerators, right? So first function is what? Sin x minus cos x. Second function for numerator is cos x plus sin x. Cos x minus sin x. Divided by the common denominator. What is common denominator? 1 plus sin x is cos x into dx. You can see something happening here. Sine plus sine minus sine cancels out. Minus cos plus cos cancels out. So all you're getting is 0. 0 dx. So 0's integration with respect to limit is always 0. If 2i is 0, therefore i is also equal to 1. So the integration value of this integration is 0. That's it. The answer to this question is 0. Answer is option A. Is it clear? Okay. Now, integration is what? Sorry. Integration is 0 to pi by 2. 1 by 1 plus root of cot x into dx. Now guys, let me give you some hint. Okay. Hint an idea. Now based on my extensive practice of problem, what I realized is whenever I see cot x function, cot x, tan x, sec x, cosec x, these 4 main functions, whenever I see, I never try to solve the problem in that function unless and until okay, cot x derivative is what, right? Cosec square x. So somewhere cosec square is there in the function, then I will manage with that. Okay, even for tan derivative, tan x derivative is sec square x. So if in tan and sec square is available in the function, then I will manage with that. Similarly, for sec x, the derivative is sec x tan x. So something like that is another function is available, then I will do with that. If nothing is available, I will always go for sine and cos. So instead of doing the problem in cot x, I'll be doing the problem in sine and cos x. So let me show you how to manage that. So what is cot x? What is cot x? If you remember, it is what? Square root of cot x can be written as what? Cos x divided by sin x. Now cross multiply it. So 0 to pi by 2. 1 dx is there. 1 divided by what is that? Root of sin x by cross multiplied plus root of cos x whole divided by what? Root of sin x. Okay, into dx. Now I is equals to 0 to pi by 2. That denominator root of sin x will come, root of sin x will come in the numerator. So root of sin x coming in the numerator. Denominator is what? Root of sin x plus root of cos x. Now some people might argue that this is far more complicated function, but actually this is easy. And I'll show you how to manage that. Let's recall the same property. The property that we did in earlier problem. What is that? 0 to a f of x dx is 0 to a f of a minus x. Now, why are you going to this? Obviously, root of sin x is not a standard function. So forget that. Now, even if I take root of sin x is equal to t, how will I manage then cos x? That's another troubling term there. Though that is also problematic. Then partial fraction, obviously, denominator, there is no algebraic function, so that is also gone. So the only thing that is available is properties. Now, here also again, limit is not the issue. Limit is very easy to manage. Function is the issue. So I manage with the function. So 0 to pi by 2. Wherever there is x, I'll be replacing by what? Pi by 2 minus x. Divided by square root of sine pi by 2 minus x plus square root of cos pi by 2 minus x into dx. Now, as we discussed earlier, sine pi by 2 minus x is what from the last problem? That is root of cos x. Cos x, no? Here, root of cos x plus root of sine x into dx. Now, think about this. Let us say this is equation 1 and this is equation 2. Can you see something here? The denominator is the same. Na? A plus b plus a is plus, however you write is always same thing. So root of sin x plus root of cos x is same as writing root of cos x plus root of sin x. The denominator is same. So if denominator is same, I can simply add it up, right? So add what? 1 and 2. So I plus I becomes what? 2i is equals to 0 to pi by 2. What is the numerator of this? Root of sin x. Second is root of cos x. The numerator just add it up. Divided by what is the common denominator? Root of sin x plus root of cos x. Whole thing into dx. So you can see that same functions are coming in numerator and denominator. So you can cancel it out, right? So 2y is equals to 0 to pi by 2 into dx. That's what I'm going to get because of the cancellation of the upper and the numerator and denominator function. Now 2y is equals to what is the integration of dx? It is x. Limit is from 0 to pi by 2. When I apply the limit, I am just going to get pi by 2 minus 0, which is technically still pi by 2. So 2i is equals to what? Pi by 2, or I is equals to what? Pi divided by 4. And that is the answer. Is there an option like that? Yeah, answer is option pi divided by 4. Now, some people make a silly mistake that after adding, you get 2 on the left hand side. Na? So to get integration, you always have to take the 2 on the right hand side. So some people forget to take that. For them, the value pi by 2 is also option is available, but it's the wrong option. Correct answer is pi by 4. Okay, understood? Okay, let's try to work it out. Again, I is equals to 0 to pi by 4 log of what? 1 plus tan x into dx, right? We can keep it tan x and try to work it out. Let's convert into sine and cos. Let's go to the again function. Let me write it now. Let me properly write it now. 0 to pi by 4 log of 1 plus tan x, right? Now guys, pi by 4 is a very important value, important angle with tan x. So because of that important value associated there, I won't be actually replacing tan x into sin x by cos x. By mistake, I took it as pi by 2. That's why the answer is wrong. Okay. Please understand my mistake. I took the question in pi by 2. That's why the question is wrong. So you have to replace by what? Pi by 4. So pi by 4, don't replace tan x. Keep it like that. There is some advantage with pi by 4. And I'll show you that. So 0 to pi by 4 log of, I'm applying the property. What is that? 0 to a minus x. So here 0 to pi by 4. So tan of pi by 4 minus x. Pi by 4 minus x. Okay, so this is tan pi by 4 minus x. Now, if you remember trigonometric properties, tan pi by 4 minus x is a famous function. It is what? 1 minus tan x divided by 1 plus tan x. Okay, 1 minus tan x divided by what? 1 plus tan x. So I is equals to 0 to pi by 4 log of 1 plus 1 minus tan x divided by 1 plus tan x. Okay, for those who don't remember this property, you can actually work it out from like this. You remember this tan A minus tan B. The formula is tan A minus tan B divided by what? 1 plus tan A tan B. Okay, so this is the formula, and either here A value is pi by 4, B value is x. So that's how it gets converted. And this is actually a famous trigonometric relationship also. Now let's cross multiply it. 0 to pi by 4 log of what is the denominator? 1 plus tan x, right? So cross multiplied. So 1 plus tan x plus 1 minus tan x divided by 1 plus tan x. So obviously what gets cancelled out? Tan x gets cancelled out. So I is equal to what? 0 to pi by 4 log of 2 divided by 1 plus tan x. That's what I'm getting here. Okay. Oh. Let us call this 2. And let's say where is the origin function? Yeah. Let us call this 1. Again, let's do the same procedure. Add 1 and 2. Add 1 and 2. So left side I get 2y. Limit is from where? 0 to pi by 4. This is pi by 4, okay? First function is what, right? Log of 1 plus tan x plus log of 2 divided by 1 plus tan x. Okay, now guys, do you remember this property? Log a plus log b is what, right? Log of ab. So here also same thing is happening. Log of 1 plus tan x plus log of 2 divided by 1 plus tan x. So this is addition. So I can simply multiply it. So 2y is equals to 0 to pi by 4 log of 1 plus tan x multiplied by what? 2 divided by 1 plus tan x. Now 1 plus tan x, 1 plus tan x can be cancelled out. So what do I get? 2y is equals to 0 to pi by 4 log of 2 into dx. Now, what is log of 2? If I take it outside the integration, I get integration of dx. What is integration of dx? X. Now apply the limit. 2y is equals to log of 2 into pi by 4 minus 0 or pi by 4. So I is equals to pi log of 2 divided by 4. That is answer. Let's check it out. Pi by 8 log of 2. That's what we got now. Pi by 4 log of 2, sorry. I miss pi by 8 only. When I take 2 here, so pi 4 into 2, yeah. Pi by 8, correct. Pi by 8 log of 2. Let's go for one more problem and then we can wind up today's session. Let's do 0 to pi x sine x by 1 plus cos square x. Okay, let's work it out. I is equals to 0 to pi x sine x divided by 1 plus cos square x. So what is the troubling part? Troubling part, there is algebraic, there is trigonometric. These are two functions which are not related to each other. Now you can relate it by some complicated method like Taylor series and everything, but forget it. That's an infinite series, so that's also creates its own issues also. So because of this, again, I cannot apply standard formula. I cannot do substitution. I cannot even apply partial fraction because denominator there is no algebraic function. I'm getting a function which is trigonometric, higher power of trigonometry. So that's why it is failing. So the only property available to me is the property that I discussed. So what I'll do is wherever there is x, now here the limit is from 0 to pi. I'm replacing by pi minus x. That is pi plus 0 is pi, so pi minus x. Sine what? Pi minus x divided by 1 plus cos square into pi minus x. Okay, now guys, we have to recollect something. Sine pi minus x. Whenever you add or subtract by sine, your answer is always going to be sine function itself. Now, whether it is positive or negative, pi minus x is in the second quadrant. So, second quadrant sine is positive. So, that's why the original function sine will come out as positive sign. Now, cos pi minus x. That is cos x only, but it is negative value of cos x. Why negative value? Because second quadrant sine and cosec are positive. Cos is positive in the fourth quadrant. Pi minus x is lying in the second quadrant. Okay, so that's the issue here. Now, based on this, let's simplify it. So 0 to pi. Pi minus x will remain as it is. Numerator is what? Sine pi minus x. So that will become cos x divided by. Something is wrong. Yeah, not cos x, sine x only. Sine x. Now, 1 plus, when that cos x becomes minus cos x, so minus cos x is the whole square. Negative value square is again positive itself, so you don't need to worry about it. So 1 plus, instead of writing cos x, minus of cos x, I'm writing it as cos square x. Okay, now guys, let's add 1 and 2. So let's call this 2. That's the original function we started with. This, let's call this 1. Now I plus I is what? 2i. So 0 to pi. Now again, denominators are same. Numerator, some part is also same. So let us take that as common. 1 plus cos square x into sine x. Let's take it common. So now if that is the case, then the only thing that is remaining is one is that pi and the second is pi minus x. Okay, into what dx. You can see that xx gets cancelled out. Pi is remaining. Pi is a constant, so I can take it outside integration. So 2y is equal to pi, 0 to what? Pi. All I'm going to get is sine x by 1 plus cos square x. Now there's a way to approach this. Let's say cos x is equal to some variable or some variable z. Cos x is equal to what? Z. If cos x is z, minus sin x will be what? Dz by dx. Or I can say that sin x dx. This entity is equal to minus of dz. Okay, so now let's substitute. So 0 to pi. Again, normally I don't change the variables. I told you that's my approach. So next, sin x function will become what? Z. Sin z, sin x dx will become dz. That is technically minus dz. Minus dz divided by, what is that? 1 plus cos z is cos x is z. Now, so 1 plus z square. Pi outside. 2y left side, pi outside. Okay, correct. Next. 2y is equals to pi into, or I can take minus common outside. So minus pi into 0 to pi dz divided by 1 plus z square. Now this has become a standard form. Dx divided by 1 plus x square, the integration of that is tan inverse of x minus pi into tan inverse of e caseless z 0 to pi. Again, I told you since I didn't change the limits, I have to come back to the original function. Okay. So what is the original function? What was z? Cos x is equals to z. So convert into original function. So 2y is equals to minus pi tan of what cos x, right, is from 0 to pi. Now please substitute the values. Minus pi into cos pi. What is cos pi? Cos pi is minus 1. Remember, cos pi inside the, when I put cos pi is minus 1. So I get tan of, sorry, tan inverse. Tan inverse of minus 1 minus lower limit is 0. Na? So tan inverse of, something is wrong. Right? When I put 0, cos 0 is 0. Cos 0, sorry, cos 0 is 1. So I get tan inverse of 1. Technically, yeah, correct. Now, guys, you might be asking, what is tan inverse of minus 1? What is tan inverse of minus 1? Minus pi by 4. Minus. What is the lower limit? Tan inverse of 1 is what? Pi by 4. Now, minus pi by 4 minus pi by 4 is minus pi by 2. This you won't be able to see here. Let me write it in another page. So 2y is 2y is equals to minus pi into minus pi by 4 minus pi by 4 is technically minus pi by 2. So 2y is equals to pi square by 2, or I is equals to pi square divided by 4. So the correct answer to the question is pi square divided by 4. Yeah, option C. Is it understood, guys, how I manage this? Now, guys, integration problem will be expect something questions like this. So these are the questions of integration, and this is the level that is needed here.